I'm guessing most people watching this have at least one, probably two or three major cloud providers like AWS or Azure in play in their organizations. One of the things we've seen people most struggling with it is how to manage and track who's got access to do what, where, and when in which cloud provider. My experience, pretty much every single organization I work with has this as a problem. And we've got some ideas here and some approaches on new ways to fix it. So let me take you through that. First off, though, who am I and why am I talking here? I am Nick Jones. I'm a principal security consultant here at WithSecure. I lead our cloud security team. I mostly focus on AWS, which is why I'm also an AWS community builder. And I've talked about cloud security, mostly attack detection, but a few other bits and pieces as well. Quite a few conferences now. So I think I've got a bit of experience to draw on here to talk about all of this. First off, we're going to cover why identity and access management and that permissions management is such a large problem. Then we're going to talk over the current strategies I'm seeing people use. There's a few different ones, and we'll look at the limitations for those as well. Some discussion on the current tooling, which will give you an idea of things you can use at the moment if you're not already. But then really what I want to get into is the new approaches that we're working with here, some new ideas that we've got kicking around at WithSecure that we're developing on, and an idea of long-term where some of that development is hopefully going to take us. So first off, why is IAM such a hard problem? There's a few causes for it, but some of the biggest, really, most organizations' cloud estates are growing very, very quickly indeed. The rate of uptake of cloud in many organizations has gone from being something that some of the more forward-thinking organizations are doing a bit of here and there, to something that most organizations are doing, whether they like it or not, in some cases whether they know it or not, and in many cases at really quite a large scale. You'll hear a lot of organizations saying they're cloud native or cloud first, this idea that either everything's in the cloud or that we put things in the cloud by default unless there's a reason not to. That then comes with additional challenges either through mergers and acquisitions or because there's particular pieces of tech that are better in one provider than another. But the end result is that most organizations end up using at least two, if not all three, of AWS, Azure, and Google Cloud. Often we'll see some Ali Cloud involved, maybe occasionally some Huawei too, for organizations that work in China, maybe a bit of Tencent as well. IBM Cloud, Oracle Cloud for some of the more niche players, but they come up occasionally as well. So at that point, you've not just got the complexity of one cloud provider, you've got multiple in play. But on top of that, each individual provider is on average more complex than many of the legacy authentication and authorization systems that we're used to working with. Now, Active Directory was always fairly complicated. I'd argue many of the cloud providers are worse than that at this stage. And in particular, that complexity of each individual IAM system increases year on year as new services are added, new features are bolted on by the cloud providers. It just gets worse and worse. And as an example here, I've taken this from permissions.cloud, which is a fantastic website that helps you understand what different permissions do and what they're attached to and all of these kinds of things. This is a summary of AWS, right? So at the moment, we have over 12,000 unique IAM permissions in AWS, individual permissions that dictate whether an action can succeed or not. For Azure, it's actually even worse. They're clocking on for nearly 14,000 at this point. And so you can imagine just the complexity of each of these with that sort of range of different granular permissions you can apply. And as I say, that then gets even worse when you consider the average attack surface of an organization, right? Because multiple cloud providers, your source code's probably in GitHub or GitLab or a hosted Bitbucket or some other kind of source control system somewhere that might well also be in the cloud. You've probably got your documents in Google Workspaces or in Office 365. Your comms are on Slack or on Teams. You're pulling images down from Docker Hub. It really adds up, right? And when an attacker comes in from the outside, they're not considering what you think your organization looks like. They're looking at the entire perimeter as they can see it from the internet, looking for a weak point. And so most organizations really struggle to prioritize securing all of this. Most organizations don't have the budget to secure all of it. But we can prioritize effectively if we know where to focus. And one of the things that informs where to focus, I think, is both where the business is storing all its important data and running its important workloads, but also where do the highest levels of access live, who has those, and where are they working from, where are those permissions used, and how do we most effectively defend those points. And when we can't manage our permissions effectively, when we lose track of who can do what are the end results? Speaking from experience on penetration testing and red teaming engagements, things like this, generally it makes it easier to pivot between workloads or between systems and entities in the cloud. It makes it easier to escalate our privileges because if we're not careful what permissions get assigned, often there'll be misconfigurations that allows us to grant ourselves more access. And also, if the permissions aren't locked down correctly, then there's a good chance we've got access to more data than we should have, and maybe we can read more S3 buckets or gain access to more SQL Server instances to pull more data out and exfiltrate it out of the environment as a data theft exercise, right? And this is mostly based on my experiences in the security consultancy world, but we can see all of this in terms of real-world breaches as well, right? Something like 70% of cloud breaches involve stolen credentials, according to the last round of Verizon's data breach and incident report. So a lot of that is reused passwords. Some of it's leaked AWS access keys. Some of it is phishing to gain credentials. There's a few different ways it happens, but pretty much all of these breaches in the cloud are tied in some way into either stolen credentials or cases where the level of permissions that were granted made things worse than they already were. With the Capital One breach has been talked about to death. I think we've all heard about that. But one of the things that made that particularly bad was the amount of data that the attacker had read access to was more than was expected. And there's been quite a few other cases for it too. Datadog, OneLogin, Twilio, Los Angeles Times. There's a number to talk about there. And in all of these cases, the overly permissive access and the cases of having more permissions than were really needed was what did a lot of the damage. The damage could have been significantly reduced if these things had been shrunk down properly. But it's hard, right? It's hard to keep track of these things at scale. Most organizations I see work with some combination of or one of the following approaches, right? They either invest a lot of time up front into the principle of least privilege, scoping down all these permissions as tightly as we can on all these different users and entities and services within the cloud. And it's a great idea, and it's definitely something that everyone should aspire to, but it really doesn't scale, in my experience. A lot of engineering teams find themselves having to put a lot of time and effort into tuning all these different permission sets, and it's not an effective use of their time from the business's perspective. So what usually happens is people compromise on pre-made sets of permissions that apply to, well, especially to human users. You'll have like a developer role and an administrator role and a data reading role for employees who perhaps aren't engineers but need data access. And by their nature of being pre-made permission sets, they have to grant access to the different types of data in the account, because otherwise we'd have to tune that for each different use case. So you end up being able to do more or gain access to more data as a result of that, right? To try and mitigate that, what a lot of organizations then do is apply approval workflows. There's some sort of mechanism in place to request a set of permissions that then has to be approved by someone to make sure that only those who should have it are granted it. And if you're lucky, you might work for an organization where a lot of that is automated. So once the manager says, yes, you can have that, it's automatically deployed. In quite a few cases I see it's not automated and someone has to log in and change some stuff. And so while this is very common, it's seen by most organizations as a necessary evil because we don't have a better option really. And at the end of the day, it slows down engineers, reduces your development velocity, which means that it costs the business money. Right, we can track all that through. So having those approval workflows in place, however smooth they are, directly impacts the bottom line and how quickly we can get new features out and things. We then often find that those two are combined with some sort of human-driven audit to review what's currently deployed and who's currently got what access. And they're usually some sort of time-limited engagement, either by an internal security team or by an external consultant like me, to look for the worst offenders that we can find in a given time period. And fundamentally, again, it doesn't scale very well because you are fundamentally taking the time of a specialist human being and relying on that to look at all of these different permission settings. And there aren't enough good humans out there for it, and it just takes too long. It becomes too expensive to really dig into everything at the depth that we'd like to. Now, one of the things that we've done internally at WithSecure is start developing some tooling to speed some of that up so we can cover more things more effectively. And so I Am Hunter is a tool I developed a while back that allows us to look at an entire AWS organization at once, all the different permissions that are assigned, and look for cases where particularly dangerous permissions have been assigned and map out who can get access to them. So it's looking in particular for privilege escalation vectors, cases where we can read large amounts of data, and it's purely there to flag things that look interesting that we can then dive into and do some more manual review from there. So as an example here, it's noted, for instance, that we've got this AWS SSO reserved role here, which is provisioned by AWS SSO, and we can see that you can come in as a SAML entity, probably through Active Directory Federated Services or something like that. And IAM Hunter's flagged that we've got a bunch of different privilege escalation options, and so therefore this role might be quite interesting and worth looking at. Here in this case, we can ignore it. It's a core part of AWS SSO, but I think you get the idea, right? And so it will flag all of the interesting roles and users for us to then take a deeper dive into. But it's fundamentally still a way of speeding up human review. It's not really, there's no real automation there. And that's what we need to move towards to really get the ability to do this well at scale, is to take as much of this away from human effort as possible and make as much of it automated as we can. So how are people trying to automate this at the moment? The most common that you see really is what I'm calling basic analysis. So pretty much every single cloud security posture management tool or open source cloud vulnerability scanner like Prowler and things like that, they'll all look for the obvious mistakes. So things like giving people administrator access or star in AWS, global admin in Azure, other cases where there are equally highly privileged roles and permissions being handed out, basically by doing a text search to say, oh, look, we have that there. That matches one of the things we care about. That's as far as we go. It's a lot better than nothing, and I find this sort of thing catches stuff in most of the engagements that we're on, but it is only scraping the surface. And one of the biggest reasons for that is here we're looking at things in terms of lists. We have a list of entities, a list of users, and we're looking at what each individual one can do. We're not looking at it as part of a bigger picture, looking at the relationships between things. Now, this quote's been used to death at this point, but it is quite a good one, and it does make the point. John Lambert from Microsoft several years back now saying, defenders think about things in lists of vulnerabilities, lists of users, lists of permissions, whereas attackers think about the relationships between different resources and entities and systems. And as long as they're looking at those relationships, they will find things that the defenders are missing when they're just looking at these lists. And so this idea of graph-based analysis has been around for a little while now. I think the most famous example probably is with Bloodhound, which some of you might have come across, mostly for Active Directory, but they do Azure AD now as well. And bit of a messy diagram, but you can see here on the far right, we have the domain administrators group with that little diamond above it. And these are the maps of different users and groups and systems that can somehow gain access to the domain administrators group and take over the whole thing, right? So we can see here, for instance, that if we were to remove the domain users group, the group there with all those different users flowing into it at the top, from the administrators group, which is the next one to the right, that would then remove a large number of attack paths that would allow an attacker to get to domain admins, because none of those users would have that permission anymore. And that seems like a good place to prioritize and focus our efforts, rather than the individual one or two cases in the messier bottom part of the graph there. And so we can use these graph-based tools to prioritize our investments, to say where we should focus our efforts and what we should fix first. And so we've started doing this in the cloud space now as well. Bloodhound, as I say, supports Azure AD. Microsoft also released Storm Spotter as an open source tool for that. You've got PMapper and Allspecs for AWS. Cartography, I think, does a few different cloud providers at some level, but not to this degree of detail. But most of the tools are single cloud. Many of them don't account for all of the different factors. I think we're still fairly early days in this space for the cloud. As an example of something that we've been working on internally at WithSecure, IceCube is a tool for unpacking Kubernetes permission sets. And so you can see here we have the goal, cluster admin on the left-hand side of the diagram. And that is essentially the global administrator permissions for everything in a Kubernetes cluster. And we're starting from a foothold in a pod in this Kubernetes cluster on the right-hand side there. And you can see that we start off in one namespace. It turns out that there's then a service account in that namespace that's also bound to a service account in the second namespace. And once we're in that namespace, we can hop onto the cluster role binding that gets us the cluster admin there. So there's a few different hops, but because we've been able to build this map of relationships using a graph database, we can see where we start, we can see where we want to end up, and we can map out those relationships and follow those attack paths. Now, the problem here really, and the reason that some of these tools are quite limited at present, is that it's really hard to build tools to account for all of this. I've taken this diagram straight out of the AWS documentation. This is the decision tree that AWS used to decide whether a particular request to do something in AWS is allowed or denied. So we have 1, 2, 3, 4, 5, 6, potentially 7 different points at which permissions can be granted or denied. And so that is a lot of things to take account of. Most tools will take account of at least 3 or 4 of them, but probably not all. And actually then on top of that for AWS, it gets even worse because you then have to factor that entire workflow or flowchart for every role in a role assumption chain as well, because you can start in one account and assume a role and have some permissions associated with that, and that role can then have permissions to assume a second role in a different account. And so we also have to map out the graph of who can assume what roles in order to really resolve all of that. Now, I think we can agree that's quite a complex mess, and a lot of tools don't account for all of that. So we've been working on combining a more efficient and accurate resolution engine with this graph theory based approach to get us to a point where we've got a tool that can work at that kind of scale at the level of accuracy that we need, accounting for all the different pieces. And the core of this is a decision engine based on a SMT solver, which is essentially a software package that allows you to analyze whether a given mathematical formula is true for a given set of input variables, whether it's satisfiable is the word they use. And what this allows us to do is build up a data model of all these different AWS permissions policies and things that you saw in that flowchart, put all of that into a data model, and then ask the model whether user A can read data from this S3 bucket, or can system B deploy an EC2 instance into this account, things like that. And so we can effectively prove mathematically whether something is possible or not. The problem tends to be that as these things scale, they get really quite complex, as for the obvious reasons already discussed. But that means that we often need to pre-compute the models, and it's harder to build those data models and run them efficiently as an organization's cloud structure grows and expands. So we know this works in principle because AWS built Zelkova, which is the engine that powers a lot of the IAM access analysis tools that they make available. But they had a team of a lot of PhD people who really know what they're doing with this, and we don't have their kind of resources. So what we did instead was build on top of a bunch of open source tools to get most of the same results out of it. at least as a decision engine where we can decide whether a given thing is allowed or denied. So that is what IAM-SPY is. We're hoping to open source it later this summer, so watch this space. But essentially, it allows you to feed all the AWS policies in, the identity-based policies from the roles and users, the resource policies, service control policies apply to the organization, all of these different things, feed it into IAM-SPY, at which point a data model will be built, and we can ask it these questions of can entity A do thing B to resource C. And at its core, it's designed as a library. It works as a tool that you can use on the command line, but fundamentally, it's designed to be built into bigger things. And the intent is to combine that with a graph engine so that we have a way of resolving or solving these individual cases of individual permissions on individual things against individual resources. And we solve all of those at scale once. We load all of that into a graph database that says, based on all the resolution that's been done, we know that this user can do this thing to this resource, which means we can then do efficient and rapid querying pretty much no matter the scale, because we've already done all the policy resolution, right? And we can then subscribe that to live feeds from CloudTrail updates or AWS config notifications to do differential analysis as things change. So we just added a new role. That role has these policies. How does that impact our graph? Okay, we can resolve those pieces. And that's where we'd like to go to start with for AWS. We're a ways down that path already, as I say. But long term, that's only the starting point really for me. The real power here is when we start combining this with other platforms to be able to resolve across from your initial authentication point as a user right the way through to sets of permissions in other clouds. So one common model we see, for instance, is companies building their central authentication systems around Azure AD and then using AWS as their main cloud provider for deploying resources. So we need to be able to track which Azure AD users and groups can then assume which roles in which AWS accounts. But from there, we can then also say, given that these users can assume this role, what can they then do inside this Kubernetes cluster over here? Because we can resolve the Azure AD permissions, the AWS permissions, and the Kubernetes permissions, and tie all of that together. Or likewise, looking at the software as a service end of things, someone's logged in through Okta or OneLogin or Auth0, your single sign-on platform. They've authenticated to Salesforce. What can they do in Salesforce? And you can track all that access through the software as a service platforms too. Now, this is a lot of engineering effort. This isn't something that you're going to be seeing from us by sort of September, October or something. But this is where we see our vision for not solving the identity and access management problem in the cloud, but certainly getting a much better handle on it than we have today. I think this is going to be really powerful, both as a tool to support experts doing their own thing, but also to provide engineers with an understanding or a better understanding of what they're doing when they set individual permissions on things. I think it's got more broad applicability than just the security teams. And long term, once we've got that, there are some really exciting places we can take it, I think. So I've already said, long term, we'd like to build out this to cover not only the different cloud providers, but software as a service platforms, Kubernetes, etc. But then once we've ingested all that data and we can do things with it, what can we do? So exploring and auditing access is sort of the baseline. That's the bare minimum of what I'm aiming for here. Really what I want to get onto is being able to do things like, say, only these 5 users should ever be able to log into our AWS organization management account. And if we ever end up in a position where the graph says that other people can do that, we know we've got a problem because only our cloud management team should be able to do that. So the second the graph indicates that that's possible, we can fire an alert on that and say, hey, something's gone wrong. You need to go investigate these specific changes that were made or why this new set of users suddenly has access. We can do things like say, only these particular sets of users in the organization are cloud engineers, and so therefore they're the only ones who should be able to deploy resources into Azure. We should never have someone in HR in a position able to create new virtual machines in Azure. Only sales should ever have access to Salesforce, things like this. And we can also use this to inform detection and response. We've got an alert to say that a particular user's endpoint's been compromised. How bad is that for us? What's the potential damage? we can use this to understand what data, what systems in the cloud that user has access to. And in cases where we've got quite a wide breach, it allows us to prioritize who we're locking down first, whose access we're looking at most closely, all of these kinds of things to allow us to react most effectively when the worst does happen. So to wrap up, really what I'm saying here is that IAM is hard. Everyone finds it hard. We know it's complicated. And the cloud providers, by virtue of building these very capable systems, have also made that far from as easy as it could be. And I think our experiences in the on-premises world with Active Directory and Bloodhound and tools like it have already shown us that that graph-based analysis is essential. But that really now in the cloud, when we've got all these different systems, multiple providers in play, software as a service, the only way we can really effectively tackle this problem is with a platform that allows us to work across all these cloud providers, see the relationships between them so that we're not losing stuff between the gaps, and also then supports our main SaaS platforms. That's where I see this going long term. So yeah, watch this space. And with that, thank you for listening.